Welcome back. So now we're going to continue with the second type of volcano that you will encounter. Okay, for shield volcanoes, for shield volcanoes, what are the examples? In the textbook, you are given one example, Mount Washington in USA. So you take a look, a shield volcano, although we talk about it having a wide base and overall a lower height, bear in mind that shield volcanoes can still be upwards of 3,000 meters tall. So if you're at a location that's 3,000 meters tall, I bring you back to our concept of weather and climate. Right, 1,000 meters, you drop 6 to 6.5 degrees Celsius in temperature. So at 3,000 meters, we are actually looking at a 19.5 degrees Celsius drop in temperature. So if on sea level, at the base of the volcano, you are only looking at 20 degrees or 18 degrees because it's autumn already or it's early spring. At the top of the volcano, it will be snow peaked, it will be snow covered like this. Okay, so it doesn't mean that a shield volcano is definitely a very short thing, it's like a bump in the road. It isn't. It actually still is a mountain. Um, Scale wise, is still very impressive. Okay, so Erta Ale in Ethiopia is another one. Now, Erta Ale is unique because Erta Ale is active, right? If you look back at the earlier one that we saw, okay, the earlier one which is Mount Washington is dormant. It hasn't erupted in many years, over a few hundred years, so it's in a dormant state. So if you visit Mount Washington, it just looks like a mountain. But Erta Ale in Ethiopia is active. So if you were to go near, it's a shield volcano. What you will see is what you see in the picture below, right? Actually, it's bubbling. It's constantly producing some sort of fumes and some sort of gas is being released at this area here. Now, is it dangerous living here? Of course it is, because if it erupts, it will still kill you. So moving on, the next type of volcano in your syllabus is the stratovolcanoes, okay, or also known as your composite cone volcanoes. Now, why is it composite? Because it's made up of multiple cones on the same volcano. It tends to be steeper at the summit and gentler at the base. It tends to be narrower in terms of diameter at the base. It tends to be taller in terms of volcanic height compared to your shield volcanoes, but I want to caution you that it's not a must. Okay, that's not a must. There are some of them that look a little bit more dome shaped than conical shaped. Okay, they look more like they really look more like a shield than a inverted ice cream cone. However, most of them should adopt the inverted ice cream cone shape. Okay, one unique thing is you will normally find secondary cones on the volcano slope itself. So it doesn't erupt only one directional upwards. It can erupt along any of the side vents. Okay, secondary cones by the side. If there's a path of lesser resistance, it will be a path adopted by the volcano during eruption. So it need not always erupt upwards. Huh? Many times when you're looking at stratovolcanoes, it's very deadly because you don't really know which direction will it erupt out, okay, during the eruption itself. So once again, this is a lot more complex, so I would need to give you a little bit more time to deal with this. I will put this picture up and I'll put the timer on. This section here, I will give you about 6 minutes, 6 minutes to 7 minutes. Okay, so can you please sketch this, the cross section of a stratovolcano, right? And at the end of it, we will come back and we will continue. Okay, so I'll put this up, take a look at it, and begin sketching in your space.